Hello students, today we'll discuss the block questions based on the series combination and the parallel combination of the resistances. So let's see the first block questions given at page number it is 213. Okay, so these are the questions based on the series combination of the resistances. So I'm coming to the first question. Okay, see the first question. Draw a schematic diagram of the circuit consisting of a battery of 3 cells, 2 volt each, and a 5 volt resistor, 8 ohm resistor, and a 12 ohm resistor, and a plug key, all connected in series. So connect all the first resistor is given 5, second is given 8, and the third is given 12 ohm. Okay, connected in series with a cell, 3 cells. Okay, 2, 2, 2. There are 3 cells, 2 each, means it is the 6 volt. Okay, a key also. This is the part first of this question. Okay, all are connected in. It is the first question. I think it is clear. 5 ohm, 8 ohm, 12 ohm, plug key, and the 3 cells of 2 volt each connected all in series. It is the first question. Now come to the second question. In this question, you have to redraw the circuit diagram and you have to put a meter and the voltmeter for the readings. Okay, read this question. So according to question, I am making this diagram again. Okay, the same diagram you have to redraw. Okay, and you have to put a meter and a voltmeter also. Suppose this is the key, this is the key, it was the key. Okay, it was the key. Put a meter also in series, and you have to put a voltmeter across 12 ohm resistor. It is the V. Okay, across the 12 ohm. It is the 8 ohm. It is the 5 ohm. Okay, it is the 6 volt. So now you have to find the readings in the ammeter and the voltmeter. See, first of all, see what is the total resistance. See what is the total resistance in the circuit. Okay, I'm solving here near this circuit so that it may be clear. So R, what is the R? Total R. It is the 5 plus 8 plus 12. 5 plus 8 plus 12, all are in series na. So it is the 25 ohm. Clear? So I current, what will be the current? It is V upon R. V is here 6. So 6 upon 25, that is the 0.24 ampere is the current. Okay, now it means because the current, it is in series na, so what will be the value of the current passing through 12 ohm? It is again this value. So it is, you can say the current through 12 ohm, it is equal to 0.24 ampere. Same amount of current will pass. I think it is clear. So that's why potential difference across 12, it is equal to, therefore V is equal to IR. I is here 0.24 and the R is here 12. So it is 2.88 volt. Okay, and you can say potential difference across 12 ohm. I think it is clear. Is it clear? This is the question number 2. So these are the questions, 2 questions based on the series combination. Now come to the another block questions based on the parallel combination. Interesting questions are there. So now come to the block questions answer based on parallel combination. Okay, combination. Page number, it is given 216 of your NCERT. Now coming to the first question, I am taking the first question. First question is, judge the equivalent resistance when the following are connected in parallel. Okay, so there are two parts given. So in first part, A part, okay, so parallel means 1 upon R. What is the formula? 1 upon R is equal to 1 upon R1 plus 1 upon R2, like this. Okay, this is the formula. So 1 upon R, here the values, I am writing the values. In first part, 1 ohm plus 10 to power 6 ohm. Okay, 2R. So you have to estimate the resistance. So R is equal to 10 to power 6, 10 to power 6 plus 1, approximately 10 to power 6, and 10 to power 6 plus 1, it is approximately 10 to power 6. So it is 1, you can say 1 ohm. Okay, so this is the value of the R in first case. Now in B part, 3 resistors are connected. So again you have to estimate 1 upon R is equal to 1 ohm, 10 to power 3, and the another is connected according to question 10 to power 6. Okay, now again find. So it will give 10 to power 6 plus 10 to power 3 plus 1 divided by 10 to power 6. Okay, 10 to power 6, taking to the common. So now from here, R is equal to, it is 1 upon, so R is equal to 6 zeros divided by, okay, when you add this, so it is equal to the 0.999, not exactly 1. Okay, so this is the resistance in B part. Now come to the question number 2. Okay, in question number 2, an electric lamp of 100. Okay, 3 resistances are given. 3 resistances are given and connected to parallel, in a parallel to 220 volt. Okay, so first of all, find the total resistance. 1 upon R, 100, 30, and another is connected 500. Okay, 100, 50 and 500. 100, 50 and 500. 3 resistors are connected. So it is, you can say 5 plus 10 plus 1 upon 500 upon 500. So from here, R is equal to 500 upon 16, or you can say 5 upon 16 is sufficient. So I is equal to V upon R. Here the V is given 220. So 220 upon R is given here 500 upon 16. So when you solve it, you will find it is the 7.04 ampere current. Okay, now it is asked what is the resistance of an electric iron connected to the same source that takes the much current at all the 3 appliances, and what is the current through it. So this is the current, and from the formula V is equal to IR. Suppose the new resistance you have to find here, R dash. So R dash is equal to V upon I. V 220 it is given, and the I is given here 7.04. So the resistance of that appliance is equal to 31.25 ohm. Okay, this is the answer. Okay, so if you replace all these by another appliance, so the resistance of that appliance will be equal to this side, this value. Okay, because the same current is flowing here. So current flows in a circuit according to the, or as per the resistance. More resistance, less current. Okay, so it was the question number 2. Now see the question number 3. Okay, I am taking the question number 3. What are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? So simply you have to tell what is the advantages of parallel. Okay, so you know very well, first point, V is constant in parallel. V is constant in parallel. होता है ना? It is always parallel. And second, I is distributed according to the resistances, and the resultant equivalent, that is the R equivalent, is always less. Okay, always less. That is the resistance of all the appliances connected in parallel becomes very less. These are the main two advantages. Okay, now coming to the question number 4. Okay, I am taking the question number 4. See the question number 4. Question number 4. How can 3 resistors of 2 ohm, 3 ohm, 6 ohm connected to give the total resistance? A part, you have to find the 4 ohm. Okay, so see how can you find. 3 resistors are given. That is the R1 is given 2 ohm, R2 is given 3 ohm, and the R3 is given 6 ohm. So from these, how can we find the 4 ohm? This is the question. So A part, you can to find the 4 ohm, just connect first two, that is 3 and 6. So 6 ohm and the 3 ohm, take them in parallel, and it is the 2 ohm, like this. So you can see here, if the 6 and 3 are in parallel, so what is the resultant? You can see 1 upon 6 plus 1 upon 3, that is equal to 6, 1 plus 2, that is the 3 upon 6, that is 1 upon 2. Okay, this is the R dash, you can say. So R dash kitna ho gaya? It is the 2 ohm. So total R is equal to 2 plus 2 in series na. So it is the 4 ohm. So this is the way to find the 4 ohm, by connecting this way. Now in B part, to find you have to find the 1 ohm. 1 ohm, that is the less than the least value. It means simply connect all in parallel, 1, 2 and the 3. 6 ohm, 3 ohm and the 2 ohm. Connect all in parallel. So you will find the resultant as 1. Say here 1 upon R is equal to 1 upon 6 plus 1 upon 3 plus 1 upon 2. So it is 6, 1 plus 2 plus 3, that is the 6 upon 6, that is equal to 1 ohm. So R is equal to 1 ohm is the answer. ठीक है? Okay, this is the question number 4. Now come to the last question, question number 5. See the question number 5. What is the highest and lowest? So R1 is given here 4 ohm, R2 is given 8 ohm, R3 is given 12 ohm, and R4 is given 24 ohm. So what is the maximum possible, maximum resistance? It is always in series, na? Always in series. So R is equal to, add them, 4 plus 8 plus 12 plus 24. So you will get, it is 48 ohm. It is the maximum. And minimum, it is always in parallel. It is in parallel. So connect them in parallel. Okay, that is the 1 upon R is equal to 1 upon 4 plus 1 upon 8 plus 1 upon 12 plus 1 upon 24. Okay, so 24, 6, 3, 2 plus 1. So 9, 10, 12 upon 24. That is the 1 upon 2. So R is equal to 2 ohm. So this is the minimum value possible. So all these are the questions related to the series and the parallel combination. So in next video we'll discuss about the heating effect of the electric current. Thank you students.